So moving on to the first type, which is pulse code modulation or PCM. It is a digital scheme for transmitting analog data. The message signal is represented by a sequence of coded pulses, and these signals are binary, which can only have two possible states, and that is logic 1, which means high, or logic 0, which means low. So instead of a pulse train, PCM produces a series of numbers or digits, and hence this process is called as digital. A signal is pulse code modulated to convert its analog information into a binary sequence. PCM can digitize almost all forms of analog data. So these are the main steps to consider when digitizing an analog data. This is just an overview of the three steps, which are sampling, quantization, and binary encoding. The first step is sampling, which converts an analog signal to discrete signal, or the PAM signal. And then it goes into quantization, which provides finite sampling levels, or the quantized signal to sampling signals. And finally, it goes to binary encoding, which generates binary sequences depending on the zone of a particular sampling value. At the very start of PCM generation, the signal must be filtered first to limit the maximum frequency as it affects the sampling rate, because the sampling rate should be greater than or equal to twice the maximum frequency of the message signal so that the signal can be deconstructed back. And filtering should also ensure that the signal is not distorted, so high frequency components that may not affect the signal shape is removed. So next, after filtering, the analog signal goes through sampling, which is the process of generating pulses of finite width and of varying amplitude equal to the instantaneous amplitude of the analog signal. The number of pulses per second is the sampling rate, and according to the Nyquist criteria, Fs, or the sampling frequency, should be greater than twice the Fm, or the input max frequency of the message signal. So after that, it goes through quantization, which is the process of instantaneous amplitude of the analog signal at each sampling is rounded off to the nearest of predetermined levels. And in this process, it reduces the excessive bits of the sampled output and compresses the value. After that, it goes through encoding, where quantization intervals are coded in binary form. For example, quantization intervals are 8, 16, 32, or 64. These numbers can be represented by 3, 4, 5, or 6 binary digits or bits respectively. So the output of a pulse code modulator is thus a series of binary numbers, each represented by some power of 2 bits. So quantization intervals will be in powers of 2. And of course, after passing through a channel or a medium, the signal reaches the receiver where it must be decoded. So the output of the channel has one regenerative repeater circuit to compensate the signal loss and reconstruct the signal. It also increases the strength of the signal. The signal then passes through a decoder to decode the pulse-coded waveform to reproduce the original signal. After the digital to analog conversion is done by the regenerative circuit and the decoder, a low-pass filter is employed, called as the reconstruction filter, to get back the original signal. So this is the block diagram of the whole process of PCM. It starts with the analog message signal and passes through the filter, and then goes through the three main steps to digitize the analog signal, and then goes through a medium or a channel, and then goes through the receiver, which is basically the opposite of the transmitter section, in order to deconstruct the signal to get the original message signal.
All eyes love itlog. Dahil siksik sa protein and vitamin A. Nakakalinaw ng mga mata. I love my itlog. Ang kalusugan mo ay nasa iyong mga kamay.
Now, let's go through some important basic terms for this topic. Let's start with dynamic range and resolution. Dynamic range is the ratio of largest to smallest value analog signal. Resolution is the smallest analog input voltage change that can be distinguished by the A&D converter. This is represented by delta, and its equation is VFS over 2 raised to n. VFS is the full-scale voltage range of analog signal, which can be computed by maximum voltage or peak voltage minus the minimum voltage, and n is the number of bits in the digital code word. Another term that we should know about are bitrate and bandwidth requirement. Bitrate of a PCM signal can be calculated from the number of bits per sample multiplied with the sampling rate, or n times fs. Bandwidth requirement to transmit signal depends on the type of line encoding used. A digital signal will always need more bandwidth than the original analog signal. This is because the theory proves that the bandwidth requirement of an impulse signal is infinite. Therefore, the bandwidth requirement that is needed for that is also infinite. So we go through some sample problems. The first problem is the bandwidth of a TV signal is 4.5 megahertz. If the signal is converted to PCM bit stream with 1024 quantization levels, determine the number of bits per second generated by the PCM system. So bits per second pertains to the bit rate, so that is what we're looking for. And we see the given, which are FM, or the frequency, max frequency of the message signal, that is 4.5 megahertz, and the quantization levels, which is 1024. So first, we look for Fs, or the sampling frequency, and we know that it is twice the message frequency, or the maximum frequency of the message signal, and that we get 9 mega samples per sec. And to get the n, or number of bits required to encode a sample, it is log 2 the quantization levels, and so we get that. And with knowing the Fs and n, we go back to its equation, which is n times Fs. We get 10 times 9 mega, and it is equal to 90 mega BPS. So for the second problem, in a PCM system, the signal m of t is sampled at the Nyquist rate. The samples are processed by a uniform quantizer with step size 0.75 volts. What is the minimum data rate of the PCM system in bits per second? So again, we are asked what is the bit rate for this problem. And we are given a signal in this form. And we are also given the resolution, or the delta, which is 0.75 volts. So from that given, we can also get the maximum frequency of the message signal, since we can get that from the omega equals 2 pi fm. So we get fm to be 50 hertz. And from that, we can also get the sampling frequency, which is 2 fm, or 100 hertz. And since we need n in order to solve for bit rate, because it is n times fs, we have to find out the maximum voltage and the minimum voltage for this problem. And in order to do that, we have to convert the signal, the analog signal, to a standard signal. So by using approximation, we solve for it, and we get square root of 2 cosine 100 pi t minus 45 degrees. So from there, we use the equation of resolution, which is delta equals V max minus V min over 2 raised to n, in order to get n. After obtaining n, which is equal to 2, we can solve for bit rate, which is n times fs, or 2 times 100, and it is 200 bps, or bits per second. Now let's go to advantages of PCM. So these are some of the advantages of using PCM. It is robust to noise and interference. It is compatible to different classes of traffic in the network. It has efficient regeneration. It is secure, and it is easier to implement complicated communication systems such as telephone networks. Some of its disadvantages are: in linear quantization, there is more distortion, and to decrease the distortion, the number of levels has to be increased. And so the bandwidth requirement is high in comparison to other techniques. And developing pulse code modulation is a bit complicated, and checking the transmission quality is also more difficult and takes more time. So some of the applications of PCM are in telecommunication systems or air traffic control systems. And since pulse code modulation is used in compressing the data, we use this in storing data in optical disks or DVD and CD database management systems. It is also used in mobile phones and normal telephones, and it can also be applied in remote controlled cars, planes, and trains.